Let us now proceed to centroid and center of gravity. So first, let's try to get the center of gravity of two-dimensional body. What is center of gravity? So center of gravity, this is a point where the action line of the weight of the body always passes. So let us try to consider now that this is now your body. Now, the total weight of the body is now equal to W. So let us try to determine the location of the total weight of the body from the y-axis and from that of the x-axis. So the location of the total weight of the body is bar x from the y-axis and bar y from the x-axis. Now, if you try to consider differential elemental weight of the body. So this is your body, and this is now the differential elemental weight of the body, which is deltas of W. And this differential or this elemental weight of the body is located at a distance x from the y-axis and at a distance y from the x-axis. Now, our problem in here is to determine the center of gravity of this body. So if you try to recall that the moment of the resultant force about any axis is equal to the moment of all the forces about the same axis. This is true in determining the center of gravity of the weight of the body. So we now have the moment of the total weight of the body about the y-axis is now equal to the summation of moment of the elemental weight considered about the same axis. So the moment about the y-axis of your W is W multiply this one by bar x. So that is the moment arm about the y-axis. And this is therefore equal to deltas of W. So multiply this one by the moment arm, which is equal to x. Or this is now equal to W bar x is now equal to the summation of the elemental weight multiply this one by x, which is equal to, or we have W bar x is now equal to the integral of x multiply this one by d of W, or the elemental weight. Similarly, if you will going to take some moment of the total weight about the x-axis is now equal to the summation of moment of the elemental weight about the same axis. So the moment about the x-axis is now equal to the total weight, which is equal to W multiply this one by bar y. And this is therefore equal to the elemental weight, which is delta W multiply this one by y. Or we have W bar y is now equal to the summation of the elemental weight of the body multiply this one by the moment arm which is equal to y. Or your w bar y is now equal to the integral of y multiply this one by d sub w. So to determine now the location of the this location of the center of gravity of a two-dimensional body, your bar x is now equal to the integral of x dw all over the total weight. And your bar y is equal to the integral of y dw all over the total weight. Centroid of areas and lines. So centroid corresponds to the center of gravity of infinitesimal thickness. Or in other words, it concerns on geometric shapes only. So let us start 4 lines. These are now your homogeneous wire of uniform cross section. Now, based on the determination of the center of gravity, your centroid, the center of gravity is the point where the line of action of the total weight of the body always passes. So in centroids, it corresponds to the center of gravity of infinitesimal thickness. So we are dealing with geometric figures or geometric shape only. 4 lines having a so these are your homogeneous wire of uniform cross section based on the equation of in the determination of the center of gravity, then the total length bar x is now equal to delta L multiply this one by x, or L multiply this one by bar x is now equal to the integral of x multiply this one by dl. Similarly, your L bar y is now equal to delta L multiply this one by y, or L bar y is now equal to the integral of y multiply this one by dl. Hence, bar x is now equal to the integral of x dl all over the total length. And bar y is equal to the integral of y dl all over the total length. You try to take note in here. Your L in there is now the total length of the homogeneous wire of uniform cross section. Similarly for areas, the total area bar x is now equal to the elemental area multiply this one by x, or you have your total area bar x is now equal to the integral of x dA. And your area, total area bar y is equal to the sum of the elemental area considered multiply this one by y, or your area bar y is now equal to the integral of y multiply this one by dA, where A is the total area. Now, let us proceed to the centroid. of composite figures. Okay, so when we are speaking of composite figures, it consists of more than. Okay, you try to take note that this consists of more than one common or spatial geometric figures. Okay, so it consists of more than one common or spatial geometric figures. So what are these common spatial geometric figures or common or spatial geometric figures? So we have your straight line, then we have a semicircular arc, we have a quarter circular arc or the arc of a circle. Now, whereas for areas, we have square, rectangle, triangle, and circle, and so on. So how are we therefore going to determine the centroid of composite figures? So to determine the centroid of composite figures, we start for lines. So for lines, your L bar x is now equal to summation L multiply this one by x. Your small l, summation L, your small l in here is the length of one geometric figure. That's why we have summation, because composite figures consist of more than one spatial or common geometric figures. And your L bar y is now equal to the summation of L multiply this one by y. Now, similarly for areas. For areas, so area bar x is now equal to the summation of A multiply this one by x, and area bar y is equal to the summation of A multiply this one by y. This small a in here is the area of one spatial geometric figures. So your composite figures consist again of more than one geometric figures. That's why we now have the summation in there. So if you get now the centroid of a line, bar x is equal to the summation Lx all over the total length, bar y is summation Ly all over the total length, and for areas, bar x is equal to the summation Ax all over the total area, and bar y is equal to the summation Ay all over the total area. So for this figure, let us try to locate the centroid of wire bent in the shape shown. So this is now your wire bent in the shape shown. So let us try to consider that this length is now equal to L1. This length in here is equal to L2, and this length in here is equal to L4. So that the total length of the bent wire is equal to 300 plus 600 plus 400. So let's start first with L1. So for L1, we have your L1 in there is, so we have the z-axis, we have the x-axis, and then we now have your y-axis. So this is your z-axis, this is the x-axis, and this is now your y-axis. So now the first line in here is L1. So this is now your L1. So your L1 is equal to 300 millimeter. So this is equal to 300 millimeter. So we now have L1 is equal to 300 millimeter. So we have your X1 in here. So the location of the centroid X1, so this is now your X1. And the look X1 in here is now equal to, this is now your X1. So we have your X1 is equal to 150 millimeter. Your Y1 is equal to 0. It has no distance because this is along the x-axis. And your Z1 is also equal to 0. So this is your L1 equal to 300 millimeter. So let's proceed to the second line, and that is now your L2. So again, we have the x-axis, and then we have the y-axis. This is the x-axis, this is the y-axis, and this one is now the z-axis. So we have your line 2, which is now your L2. So this is your L2. So your L2 is equal to 600 millimeter. Now this one in here is 300 millimeter. So that is 300 millimeter. So the centroid of this line in here is now located at this point. So that is now the centroid. Now such that we have your X1. So this is now your X2. For the second line, I'm going to consider this one as X2. And this one in here is now your Y2. That is now your Y2. Now so that your L2 is equal to 600 millimeter. And your X2 is equal to 300 millimeter. Your Y2 is now equal to the centroid is at the center, 600 divided by 2, and that one is equal to 300 millimeter. And your Z2 is equal to 0. Next, let us proceed to the next line, and that is your L3. Now we have your x-axis. This is now your z. So we have your x, and then we now have your y-axis. So z, x, and this is now your y. So we now have your y-axis. So this is therefore parallel to the y. So this is your line, which is equal to 400. Okay, so this is your line 3. So we have your L3 is equal to 400 millimeter. 400 millimeter. So this is now your X3. So if you this is now the centroid of the line. So that is therefore the centroid of the line. Hence, if you try to take a look at this point, this is now your this one in here is now your X3, and then we have your this is your Y3, so that is now your Y3, and this distance up to this distance is now your Z3. So we now have your line L3 is 400 is equal to 400 millimeter. And then we now have your X3 is equal to, you try to take note that this one in here is 300 millimeter, and this distance is 600 millimeter. So X3 is 300 millimeter, and then your Y3 is equal to 600 millimeter, and your Z3 in here is equal to, it is below the origin of the X, Y, and Z axis. Therefore, your Z3 is equal to negative. So, kalahati ng 400, so that is negative 200 millimeter. So, let us tabulate the result. You have your line. So, we have your L1, we have your L2, and this is your L3, and that is now your summation. And then we have the length in millimeter. That one is 300. The L2 is 600 mm, and L3 is 400 mm. So we have your X. So your X for L1 is 150 millimeter. Then for L2, so for X, and then we have your Y for L1 is equal to 0. Z for L1, that one is equal to 0. So L multiply this one by X. So 300 by 150, so we have 45,000. So that is 45000. Then we now have your Ly. So we have 300 by 0. That is equal to 0. And now your Lz, that is 300 by 0. And that one is equal to 0. For length number 2 or L2, we have x is 300. And then your y is 300 and your z is 0. So your Lx, 600 by 300 is 180,000. So that is 180,000. And then Ly, 600 by 300 is still 180,000. And your Lz is 600 by 0. So that one is equal to 0. For the last line, which is L3, then we have your x is 300, your y is 600, and your z is negative 200. So Lx, that is 400 by 300, is equal to 120,000. 400 by 600, so we have 240,000. And then 400 by negative 200, that is minus 80,000. That is minus 80,000. So let us try to summation L, which is 300 plus 600 plus 400, or that is equal to 1,300 millimeter. Summation Lx, so 45,000 plus 180,000 plus 120,000. So we have 345,000. Summation Ly is equal to 420,000. So summation Ly is 420,000. And summation Lz is negative 80,000. So that is negative 80,000. So we now have the total length bar x is now equal to the summation Lx. So your bar x is now equal to summation Lx all over the total length. So your bar x is now equal to summation Lx is 345 all over the total length, which is 1,300. Bar x therefore is now equal to, so your bar x is equal to 265.385 millimeter. Now, your L bar y is equal to summation Ly. So, your bar y is now equal to summation Ly all over the total length. So, bar y is now equal to summation Ly, which is 420,000 all over the total length, 1300. So your bar y in here is now equal to 323.077 millimeter. We now have your L bar z is now equal to summation Lz summation Lz. So we have your bar z therefore is now equal to summation Lj all over the total length. So bar j is now equal to, so your bar j is now equal to minus 80,000. Summation Lj is minus 80,000 divided by the total length, which is 1300. Hence, your bar j is now equal to negative 61.538 millimeter. So the centroid of the composite line shown as 265.385 mm in the x-axis, 323.077 in the y-axis, and negative 61.538 millimeter in the z-axis. Next, we have this figure, and let us try to locate the centroid of this wire bent into this shape. At this time, I'm going to consider this one in here as L1. So this is now your L2, and the semicircular arc is L3, and the straight diagonal is L4. So let's proceed to L1. At this point, now we have, this is the x-axis. Okay, so this is now your z-axis. And then we have the x-axis. And then we have the y-axis. So we have your x, y, and this is now your z. So this is now your line 1, or we have L1. That is your L1, and your L1 is sequal to, that is sequal, the radius of the semicircular arc is 4, so is 4 inches, and therefore 4 meters, I mean, and this is 4 inches. Okay, so we have 4 inches. So let's try to determine now the centroid of this line is located at this point. And therefore, this is your x1. So we now have your x1. And this is now your and this is therefore your z1. So this stands up to that. So this is your x1, and this one in here is your z1. Okay. So let us try to have now your L1 L1 is equal to, so your L1, that is equal to 4. So your L1 is equal to, we have 4 inches. So that is equal to 4 inches. And then your X1. So we have 4 over 2. So your X1 is equal to negative 2 inches. Now you try to take note that this is back of the origin. So we have negative. Your Y1 is equal to 0 and your Z1 is equal to, that is your Z1, and that one is equal to 6 inches. Let us proceed now to the second line. So we have for your L2, so this is the Z-axis. We have the X-axis. And then we now have your Y-axis. This is X, Y, and that is now your Z-axis. This is your L2. So this one is now your L2. So your L2 is equal to 6 inches. So the centroid of this L2 is half of this. So that is therefore the centroid. And therefore, we now have your X sub 2. This is now your X sub 2. And then we have your Z sub 2. So this one in here is now your Z sub 2. So if you try to prolong this one in there, so this is your Z2. This one in here is your Z2. So let's try to determine now your L2 is equal to 6 inches. So your X sub 2 is equal to, the radius of the semicircular arc is 4 meters. Hence, this one in here is equal to 4 meters. 4 inches I mean. That is 4 inches. So your X2 in there is equal to 4 inches. Your Y sub 2 is now equal to 0. And your Z sub 2 is now equal to half of 6. And that one is equal to 3 inches. So let us proceed to the next line. And this is now your semicircular arc. We have your Z-axis, and then we have the X-axis, and then we have the Y-axis. So we now have your semicircular arc, which is now your L3. Okay, you try to take note that this is your semicircular arc. And this is now your L3. So this is your L3. So this is your 4 inches, and that one is also equal to 4 inches. We have your X, this is your Y, and that one is now your Z. So for a semicircular arc, your semicircular arc, for your semicircular arc, now the length L3 is now equal to 2 pi r is the circumference of a circle. Since that is a semicircular arc, let us try to divide this one by 2. And this is therefore equal to 4 pi, or your L3 is equal to 4 pi is 12.566 inches. 12.566 inches. So your bar X in here is equal to 0. So your bar X is equal to 0. Now, if you try to refer from the table of common geometric figures, okay, in the manual that was uploaded before, now the centroid of a semicircular arc, so that is the y-axis. So if I'm going to consider that this is now your, okay, so ito yung ayon, yung x-axis natin, be sure to refer from the axis given in the table. So this is, okay, so ito yung x natin, and this is now your y-axis. So you try to take note that this is your semicircular arc. So the radius of the semicircular arc is equal to r. So let's try to consider the radius is equal to r. This is therefore the radius of the semicircular arc, which is equal to r. Now, since the centroid of the semicircular arc is located at this point in here, so at that point, and that you can see in the table uploaded, this is indicated as bar X. So this one in here is indicated as bar Y. So this is now your bar Y for a single geometric figure. So ang nakalagay doon is ala pa yung makita. So this, your bar Y in here, so your bar Y is equal to 2, so your bar Y is 2r all over pi. So that is 2r all over pi. And therefore, the centroid of this figure is located somewhere else at that point. Hence, we now have your y2. So this distance in here is now your y2. So this distance up to that is your y sub 3, I mean, because that is now the third area. So that is y sub 3. So that is your x sub 3 is equal to 0. Hence, your y sub 3. So we now have your y sub 3 is now equal to, so I'm just going to place it here, so that your y sub 3 is now equal to 2r all over pi. And this is equal to 2 multiply this by 4 all over pi, and that is equal to So that is therefore equal to 2.546. 2.546 inches. Now your Z3 in here is now equal to 0. So that is for the value of Z3. Next, for the last line, L4. So again, let us try to draw the x-axis, y-axis, and the z-axis. So this is the z-axis. This is now, so we have the x-axis, and this is your y-axis. X, and that one is now your Z. So your last line is now your L4. So we have your L4. So your L4, this is your L4. Okay, so this is now equal to 4 inches. And this one in here is 6 inches. So that your L4 is now equal to, so your L4 is now equal to the square root of 4 square plus 6 square. That is using Pythagorean theorem. And this is equal to 3, so we have 2 the square root of 13. That is 2 the square root of 13, or this is equal to 7.211. 7.211 inches. The centroid of this line is located, of course, at the middle of the line. So that is therefore the centroid. Hence, this is now your x of 1. So this is your x1. And we have now your x4 is now your fourth line. So that is now your x4. Okay, y4. And then we now have your z4 is this distance in here. So this is your z4. So let us try to determine now your x of 4. So how are we going to determine your x of 4? So first, okay, so at this point, okay, so I'm now going to erase this part. Let's try to determine your x of 4. So we have your ratio and proportion. So let's try to take ratio and proportion. So we have your x of 4 is 2. Is your x of 4 is 2, the hypotenuse L4, and L4 is 2 the square root of 13 over 2. 2 the square root of 13 all over 2. So this is x4 is to this distance, and the whole distance in here is 2 the square root of 13, hence that is 2 the square root of 13 all over 2. And then this is equal to 6 all over. So this is equal to, that is therefore equal to 4 So we have now your 4 all over 2 the square root of 13. So your x of 4 is now equal to 2 inches. Now similarly, your z's of 4. So your z's of 4 is 2. 2 the square root of 13 all over 2. Okay, so we now have, so this is now your z's of 4 is now equal to 2 the square root of 13 all over 4, all over 2, and this is therefore equal to 6 over 6 all over 2 the square root of 13. 6 all over 2 the square root of 13. Hence, your z's of 4 is now equal to 3 inches. And your z's of 4 is equal to 3 inches. Let's go back. L4. So we have your x of 4 is equal to 2 inches. Your y's of 4 is equal to 0, because this is only on the xz plane. And then your z's of 4 is equal to 3 inches. Again, let us try to tabulate the result. So we have your line. So we have L1, L2, L3, L4. So we now have the summation. We have the length in inches. So we have your length in inches. So your L1 is 4 inches. Then L2 is 6 inches. L3 is 12.566. And then L4 is 7.211. And we have your summation. So we have your x. This is your y. So we have a z. And this is now your z. So we have your lx. We have your ly. And that is your lz. So your x in here is minus 2. Your y is 0. And then z is 6. So this is minus 4. And then 0. And this one in here is 3. Then this one is 0. So this is your 2.546. 2.546. And this is equal to 2, 0. And that one is equal to 3. Okay, so Lx is 4 by 2. We have minus 8. Ly is 0. And then Lz is equal to 4 by 6. So we have 24. For L2, 6 by negative 4 minus 24. And then 6 by 0, that is 0. 6 by 3, so we have 18. 12.566 by 0, that is 0. By 2.546, so this is 31.993. 12.566 by 0, that one is equal to 0. And for L4, so we have 7.221 by 2 is 14.422. Is 14.422. And then we have 0. And then by 3 is 21.633. 21.633. So we now have the summation. This is 29.777. Summation LX is minus 17.578. 578. And then summation LY is 31.993. And summation LZ is 63.633. So let us try to determine now bar X is now equal to summation LX all over the total length. So your bar X is equal to negative 17.578 all over 29.777. So your bar X is equal to negative 0.590 inches. Your bar Y is now equal to summation LY all over the total length. So bar Y is now equal to summation LY 31.993 all over the total length 29.777. Bar Y therefore is 1.074 inches. And your bar Z is now equal to summation LZ all over the total length. And summation LZ is 63.633 all over the total length, and the total length 29.777. So your bar Z is equal to 2.137 inches. And therefore, the location of the centroid of the composite line is negative 0.59 in the x-axis, 1.074 inches in the y-axis, and 2.137 inches in the z-axis.